Go.
Good morning, this is your local broadcast station, and I am your host, Killer Keemstar. Let's get right into the news. Today we have two special guests to tell us all about photosynthesis.
Hello, it's your boy Biscuitine Trisky, and let's get right into it. So due to the recent rise in temperature, we're going to tell you the process of the plants and how they make their own food.
That is very correct. And also water, carbon dioxide, and sunlight are all used in photosynthesis.
And DPH is also used with ATP to make energy for the plant.
Wow, that's cool. Sorry, I didn't catch your name, scientist, too.
It's Hingle the Kringleberry.
That's even cooler.
Chlorophyll is a green pigment that absorbs the sunlight for the plant to use during the process of photosynthesis.
Chloroplast structure contains thylakoid membrane, photosystem 1, T, chlorophyll R, chlorophyll B, and carotenoids.
This is the light reaction. This is photosystem 2. This is photosystem 1.
So where do all these little electrons come from?
Water splitting, probably.
And where do they go after photosystem 1?
NADPH or something.
It's very nice.
This is the chemical equation for photosynthesis. This right here, carbon dioxide plus water, that goes into glucose, this giant thing, and oxygen.
Some more parts of photosynthesis that are vital to the function of photosynthesis are the ETC, ATP synthase, reductase, and the NADP+.
Now, Mr. McCringleberry, what is ETC?
The ETC,
Yeah.
it's the electron transport chain. It transports the electrons to the photosystems.
That's very interesting.
Some more parts of photosynthesis that are vital to the function of photosynthesis are the grana. They are the stacks of thylakoids. And the stroma is the open space inside the chloroplast.
Light-dependent reactions also occur in the thylakoid and absorb light, and hence the name. Light-dependent.
When photosynthesis occurs, it takes in carbon dioxide and releases oxygen as a byproduct. It is what we need to breathe.
The hydrogen from the broken up water molecules is turned into ATP, and the electrons go to photosystem 2.
Indubitably. Now, this seems like a lot of work for a plant, and this is a lot of stuff for you guys to remember. Isn't it hard to remember all this stuff?
Yes, it is. If
So
you
what
know
else
your
do you have
stuff
to tell me?
and study, it's not hard.
And do blah, 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 blah.
So what else do you guys have to tell me?
The formation of energy-strong compounds start after this. Starts to make NADPH. It starts chemiosmosis.
Next.
What was that? I couldn't quite hear you.
Chemiosmosis.
A little louder.
Chemiosmosis!
Oh, okay, thank you.
Mm-hmm.
Next starts.
Mr. Man.
Next starts the light independent reactions, which don't need any light to do their job.
This diagram shows the light reactions and the dark reactions working together. The light reactions releases the oxygen for us, and it provides the ATP and the NADPH, which is the energy, into the dark reactions. The dark reactions then recycles the NADP plus and the ADP back into this to make this, and then it just goes like this all the time.
Formation of energy strong compounds start after this and starts to make NADPH.
Next starts the light independent reactions. And they don't require any light to do their job.
No light at all.
None.
None at all.
Zero.
Interesting. Because I always thought photosynthesis revolved around light, but you're saying it's not. There's certain parts that don't require any light.
Correct.
Indubitably.
These reactions take place in the stroma, and then PGA turns into PGA.
Now, what is PGL?
You can say it.
Okay. Well, PGAL is glycerhydride 3-phosphate. I don't know what that is. I was hired to do this. Well, this reaction uses ATP and NADPH and brings ADP and NADP plus back into the light dependent reactions.
Why, that is very correct. Very, very correct.
I know.
Also correct.
Yeah.
Also, PGAL is also broken down into glucose, fat, protein, and carbs, and also RUBP.
And last but not least is the environmental influence that affects photosynthesis. Light intensity and temperature are major factors that affect the rate of photosynthesis. Light intensity can affect it. It goes up, and then it goes to a certain point, and then it just flattens out. However, temperature, it has to have a perfect temperature. If it's too cold, it just decreases. Too hot, it decreases. So it looks like this. Yep, and that.
Well, thank you for being here.
Okay.
I know I learned a lot from you fellas.
Stay classy, Saginaw.